Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to apply and evaluate weighted graphs. Weighted graphs are just graphs with a numerical value assigned to each edge that could represent money or time or distance depending on the application. In many applications, this will involve looking for a Hamilton cycle in the graph. A Hamilton cycle is just a cycle that visits every vertex. Remember, a cycle doesn't repeat vertices, so a Hamilton cycle visits every vertex exactly once. Since every pair of vertices in a complete graph is adjacent, each of the sequences of vertices in the graph is a Hamilton cycle, and there are n-1 factorial of these sequences. Let's determine the number of distinct Hamilton cycles in this unweighted graph. In this case, the number of vertices is 4, so we know that there are going to be n-1 factorial, or 4 minus 1 factorial number of Hamilton cycles. This would be 3 factorial. There is a factorial on most scientific calculators, but all that it means is to start at the number 3 and multiply each integer until we get down to 1. So in this case, that means that there are going to be 6 different Hamilton cycles. Each of them is listed here, starting at vertex A. Let's use the list of different Hamilton cycles to solve this application. My minivan broke down. I must use a rideshare service to visit 4 separate locations. The order of the stops does not matter. The weighted graph indicates the cost of transportation between stops. Find the Hamilton cycle of least weight to save me money. Alright, so this is the same graph that we just looked at, except we have a cost associated with each edge. So for example, to get from point A to point B will cost me $14, whereas to get from point A to point D will cost me $38. Each of these Hamilton cycles visits each of these edges, but in a different order, so it could potentially have a different cost. Let's start with the Hamilton cycle A, B, C, D. So we're going to go from A to B, B to C, C to D, and then back to A. In a cycle, we always return to the original vertex. So A, B, C, D is going to cost $14 plus $34 plus $38 plus $18 plus $38 for a total of $104. Let's see how much the path from A to B to D to C and back to A would cost. So we're going to go from A to B and then to D and then to C and then back to A. This would be $14 plus $25 plus $18 plus $22 for a total of $79. So the second option is quite a bit cheaper. Let's do the same thing for A to C to B to D to A. So we have A to C, C to B, B to D, and back to A. The cost would be $22 plus $34 plus $25 plus $38 for a total of $119. So it looks like the second option is our best choice so far. Continuing in this way, what you're going to notice is that we get the same 3 values for the next 3 options. So why is that happening? If you look carefully, you can see that, for example, ABDC has the same value, total value, as ACDB, $79. Why is that happening? Well, the first cycle, A to B, B to D, D to C, and back to A, covers the same edges as the second cycle, which goes from A to C, C to D, D to B, and back to A, just in the reverse order. And this always happens when we list all of our Hamilton cycles. Half of them are going to be the reverse of the other half. It makes sense that if we travel the same path but just in reverse order, we're going to have the same associated cost. So we really only need to consider the first 3 options in this case. And if you recognize that a cycle is just the reverse of one of the previous cycles, you don't have to spend time adding up the values. So I can be saved a lot of money if I use the cycle ABDC or its reverse. ABDC and its reverse are each referred to as a Hamilton cycle of least weight, and in this case the total cost associated with that cycle is $79. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Ms. Hearn Mathematics, for more math videos.